Ever wondered how your source code gets processed before actual compilation begins? That's where a preprocessor comes into play. It's a tool, or part of the compiler that takes your source code and performs a variety of tasks on it before the actual compilation starts. These tasks can including files, conditional compilation, and macro expansion. If you're a C or C++ programmer, you'll be familiar with how crucial the preprocessor is. It operates on your source code before it's handed over to the compiler. It plays a key role in code organization, reusability, and customization. It allows you to create modular and maintainable code by facilitating the inclusion of header files, defining macros, and enabling conditional compilation based on certain conditions. So, are you ready to delve deeper into this crucial component of programming? Let's dive into the preprocessor world and see how it works. First up, we have header files and inclusion. Let's dive into the world of header files. You might think of these as the unsung heroes of your code working behind the scenes to ensure smooth execution. But what exactly are header files? Well, they typically contain declarations for functions, macros, and other constructs that are used across multiple source files. Now, you might be wondering, how do I use these header files in my code? That's where the #include directive comes in. Think of it as a courier service, delivering the contents of a specified file right into your source code. Let's go through a practical example. When you're working with C++, you might often come across a line at the top of your source code that reads #include int main, std, count, hello world, std, endl, return 0. In this code, the #included line is including the iostream header file in your source code. The std.cout is a predefined object in the iostream header file that represents the standard output stream, and it's used here to print hello world on your screen. By including the iostream header file, you're essentially importing the necessary tools to perform input and output operations in your code. Without it, your code would be like a mechanic without a toolbox, unable to carry out the necessary tasks. To sum it all up, the #include directive is a fundamental element in programming that allows us to include the content of one file into another file. It's like a bridge, connecting different parts of your code and ensuring that they can work together seamlessly. That's how #include directive helps us in including files in our source code. Next, we have macros and macro expansion. Now let's talk about what macros are. In programming, macros are defined using the #defined directive. They allow us to define a symbol or a piece of code that can be replaced with a specified expression during the compilation process. Essentially, macros provide a way to simplify complex expressions or frequently used code snippets. Let's take a look at an example. Suppose we have a mathematical constant like pi that we want to use across our code. Instead of writing the value of pi every time we need it, we can define a macro for pi. Here's how we do it. #define pi 3.14159. Now every time we use pi in our code, the preprocessor will replace it with the value we defined, which is 3.14159. Let's use it in a function to calculate the area of a circle. Double radius equals sign 5.0, double area equals sign pi radius. Here, the preprocessor will replace pi with its value during the preprocessing stage, even before the actual compilation begins. But macros are not just about defining constants. They can also be used to define code snippets that we use often. For example, we can define a macro for a line of code that prints a debugging message. #define debug_msg std, count, debugging in progress, std, endl. Now whenever we write debug_msg in our code, the preprocessor will replace it with the line of code we defined. This can make our code more readable and easier to maintain. In essence, macros and macro expansion give us a powerful tool to simplify our code and make it more understandable. They allow us to define symbols or code snippets that we can use across our code, making it cleaner and more efficient. With macros, we can simplify our code and make it more readable. Moving on, we have conditional compilation. This is a powerful feature of the preprocessor that allows programmers to include or exclude parts of the code based on certain conditions. This is primarily done using directives like #ifdef, #ifndef, #else, #elif, and #endif. Let's break these down. The #ifdef directive checks if a specific symbol has been defined. If it has, then the preprocessor includes the code that follows. On the other hand, #ifndef does the opposite. It checks if a symbol has not been defined. If the symbol is undefined, then the code that follows is included. Then we have the #else directive. This directive is used when you want to include some code if the previous condition is not met. Think of it as the otherwise clause in programming. The #elif or else if directive is used to check for additional conditions if the previous conditions are not met. Lastly, the #endif directive signifies the end of the conditional block. It tells the preprocessor that the conditional compilation section is over. Let's look at an example. Suppose we have a symbol, debug, defined in our code. We can use the #ifdef directive to include some debugging code that should only run when we're debugging our program. Like so, in this example, if debug is defined, the preprocessor will include the debugging code. Otherwise, it will include the release code. As you can see, conditional compilation gives us a lot of control over what parts of our code get compiled. It allows us to easily switch between different versions of our code without having to manually comment or uncomment blocks of code. And that's how conditional compilation helps us control what parts of code need to be compiled. Next in line, we have pragma directives. The pragma directive is an interesting feature of the preprocessor. It's a way of giving additional instructions to the compiler. You might be wondering, why do we need to give extra instructions? Well, the answer is quite simple. It's because sometimes we want to control or alter the typical behavior of the compiler. For instance, imagine a header file that's included multiple times across various source files. This could lead to problems such as multiple definition errors. To prevent this, we use the pragma once directive. This tells the compiler to include the header file only once, no matter how many times it's referenced in the code. Here's a simple example. Let's say we have a header file. At the top of this file, we write #pragma once. This ensures the file is included only once during compilation. Pragma directives thus provide additional instructions to the compiler. Finally, we have stringizing and token pasting. In the world of programming, especially when dealing with preprocessors in C and C++, we encounter the # and double # operators. These two operators serve unique and interesting functions. The single hash or hash operator is used for stringizing. It converts macro parameters into string literals. On the other hand, the double hash or hash operator plays the role in token pasting. It concatenates two tokens together without spaces. Let's illustrate this with a quick example. Suppose we have a macro stringize with parameter x that uses the hash operator, and another macro paste with parameters x and y that uses the hash operator. After preprocessing, stringize hello will become hello, and paste 427 will become 427. See how fascinating that is? This is how we conduct stringizing and token pasting through preprocessor directives. In conclusion, we've delved into the world of preprocessors, shedding light on their fundamental role in programming. We've explored how they work behind the scenes before the actual compilation of your source code begins, performing key tasks that streamline your coding process. We've looked at the power of the #include directive, allowing you to incorporate header files and their valuable contents into your source code. We've seen the versatility of macros, defined by the #define directive, and their ability to replace symbols or code chunks with specified expressions. We've touched on conditional compilation, allowing code to be included or excluded based on preprocessor-defined symbols. And we've examined the #pragma directive, providing additional instructions to the compiler. These aspects of preprocessing contribute to better code organization, reusability, and customization, making your coding journey more efficient and enjoyable. That's it for today's lesson on the preprocessor. Remember, a good understanding of preprocessor directives can make your coding much more efficient. Until next time, happy coding!